Right, that's a good question. So let's see what happened. I was not so interested in mathematics in the beginning. At least that's what I thought. And my interest as a child, well, as a teenager, let's say, was more in physics. And when I say physics, I mean quantum physics, elementary particles, forces, interactions between them, etc. And I was very excited about books that I could find for general audience. And mathematics was not on my radar screen, because all that I knew of mathematics was what I was taught at school. And I didn't realize at the time how limited that material was. So even though I had no difficulty, doing well in mathematics, I always had the A's, the best grades, but I had no interest in it. I thought it was very boring and sterile and irrelevant. And so it was up until I was 15 years old, when I was lucky to meet a professional mathematician. I grew up in a small town near Moscow called Kolomna, and we didn't have much by way of higher education, but there was one small university, pedagogical university for preparing teachers. And one of the professors in there, whose name was Evgeny Evgenyevich. This is going to start sounding like a Tolstoy novel with all the patronymic names. Evgeny Evgenyevich was a friend of my mother's, and it so happened that when I was 15, I met with him, and he was very curious about my interests, so he kind of recognized that I was kind of a smart kid. And he took it upon himself to disabuse me of my ideas of what mathematics was about. And so he was very clever in setting it up, because he knew that I liked physics, and he asked me what do I like about quantum physics, and I said that I'm fascinated with the way physicists theorize all these elementary particles and building blocks of nature, etc. And he asked me, do you know about quarks? And I said, yes, of course I know about quarks. And he said, okay, but what do you know how physicists came up with this idea? And so I didn't know, and in fact I was kind of curious about it, because in the popular books never explained it. So I remember he pulled out a book from a shelf, and a big book, so kind of looked like a serious book. And he opened it up, and it was full of equations and diagrams, and some of those diagrams I saw in the popular books, but they were never properly explained. And then Evgeny said to me, he said, well, what you think that what you study in school is mathematics, but actually that's not the case. This is mathematics. And in fact, the only way that physicists could come up with these ideas that you're so fascinated by is through mathematics. So if you want to really understand it, you have to first study mathematics. And it's one of those moments which stay with you, and I have spoken about it on multiple occasions. I wrote about it in my book, and yet, even now, I talk about it. And this is something that happened, a long time ago. I still feel that energy, that excitement. So it's one of those moments when you go like, wow, something is going on. Something opens for you, a big space, a big fascinating world. And that's when I knew that I wanted to be a mathematician, In recent years, I have spoken quite a bit about the way mathematics is taught in our schools. And the analogy that I use is I say, imagine that you had an art class in which they teach you only how to paint fences and walls, but never show you the paintings of Van Gogh and Picasso. You know, that sounds crazy, but that's the way mathematics is taught, unfortunately. And I'm not being facetious, or I'm not blaming anybody. It's just the way it is. And as soon as we acknowledge that fact, the sooner we acknowledge that fact, the better. We are robbing our kids, you know, we are robbing our kids. And the way I was being robbed, it's not something just now and never happened before, or it's not something in Russia and not in France, or in America, or not in Japan. It is everywhere. It's a very limited material. Euclidean geometry is the only geometry that kids get exposed to. It's 2,300 years old. Euclid's work, very important. But so is Homer's. But we don't just read Odyssey and Iliad, we read contemporary books as well. In physics, in our physics classes, we do not follow the theories that were prevalent 2,300 years ago. We study modern physics as well. But if the situation, the way we teach math were in physics and biology classes, we wouldn't know about DNA, elementary particles, and the solar system. So, I mean, it's just such an obvious situation. And again, it's not like we have to completely remove all the stuff. All the stuff being studied is okay, you know, quadratic equations. Here we're talking about Al-Khwarizmi, you know, so what, 1,300 years ago. It is an important formula for quadratic equations, but we could also talk about rudiments of group theory. We could also talk about non-Euclidean geometry, which is actually closer to our real world. Let's say surface of the Earth being curved, our universe being curved, etc. Anyway, it's kind of my pet peeve, as they say. So, but to me, in a sense, the fact that I personally have experienced that. So I was lucky when I was 15 years old. I was lucky there was someone in my life who opened the door. And in mathematics, we need somebody to open the door, more so than in other subjects, in my opinion, because in the end, if you have a literature teacher who is not really qualified or whatever, you can just go and buy books and read them by yourself, or you can go to an art museum and enjoy and experience art. But with mathematics, if the teacher doesn't tell you, how are you going to find out? And of course, today it becomes much more acute because mathematics is, you know, when I was growing up, mathematics was not quite as integrated in our lives, was not quite as, did not determine our very being the way it is determining our life today. So it's become a much more urgent question. So circling back to your question, like what was my first memory? I don't have any memories of enjoying mathematics up until that point when I realized what a vast archipelago of knowledge I was missing, you know. So it's a small town in Russia. My parents were engineers. My father wanted to be a physicist. So actually that probably is kind of something that I followed in his footsteps. But he was denied to become a physicist because his father, my grandfather, was in Gulag, was arrested by Stalin's henchmen, and you know, just came during the night and took him away. And the family for many years didn't even know whether he was alive. Luckily, he came back 8 years later. But in the meantime, my father, who had you know, finished high school with honors, was applying to the university, and he was not accepted because they said, you're the son of an enemy of the people. So I guess, even though my parents didn't tell me that story in detail until much later, I suppose in some ways this kind of memory stays with, you know, the family, within the family. So it's a very particular life. I'm not saying it wasn't bad, but it was tainted by this terrible violence, emotional, even not necessarily physical violence, but emotional. I mean, the kind of trauma that my family went through. My grandfather on the other side was killed in the war in the first months. So my mom was, you know, 7 years old when that happened. She was the oldest was 3 sisters. So, you know, it's a lot of struggle and a lot of suffering. And so as I grow older, I kind of realize how much it actually affects and influences our lives, even as kids or as grown-ups, even if we're not fully aware of it. So in some ways, many of the things that I see, many of the things I had to do and I had to overcome were in some ways influenced by the kind of struggles and tribulations that my family had to go through in previous generations. My research is, the way, so since you asked earlier, so then what the path was that I started studying mathematics, and my first major sort of subject was in representations of infinite-dimensional algebra, so infinite-dimensional symmetries, so which was a subject connected to physics. So it kind of always warmed my heart, the fact that I never moved too far away from my first love, which was quantum physics. And so, interestingly enough, kind of a surprising aspect of it was that when I was, my first works with Boris Fagin were kind of resonated with a lot of people, but one of the ways in which they were employed or used was in the Langlands program, in the geometric version of the Langlands program. So at that time, I didn't know what was Langlands program, but Vladimir Drimfeld, it so happened that Vladimir Drimfeld, who was sort of a major driving force behind the geometric version of the Langlands program, was at Harvard, and which is where I was first when I came to the United States. And we had this, many conversations about, because he wanted to know things about my work with Fagin, which he was, at the time, wanted to use it in his project. But then I was curious, why is he interested? So that's when I probably even heard the name Langlands program, because everybody knew, even at that time, I'm talking about 1990, everybody knew the name Langlands program, but I didn't know what it was. And the more I learned about it, the more I was fascinated. And so what happened after that is that I think that what happened is I got so excited about it that most of my work since that point was on different aspects of the Langlands program. And the interesting aspect about the Langlands program is that it's really about connecting things. It is really about finding certain patterns in different subjects of mathematics, which link them to each other. Originally Langlands came up with these ideas about 50 years ago. And he was connecting actually number theory and harmonic analysis, the two subjects. In the two subjects, I cannot say that there were no connections between them. Of course, there were connections known, but he kind of took it to the next level. He found things which were absolutely crazy. Like, wow, how can that question have an answer in terms of objects? This question in number theory has an answer in terms of some things in harmonic analysis, which look totally different. So, and I think it resonated with me. It is something which is very hard to explain. I think it's in general, I always felt kind of excitement and curiosity about connecting things, not separating, but connecting. And so this was perfect for me somehow. And so then, 50 years ago for Langlands, it was but it was still vast set of questions, ideas, and conjectures for connecting number theory and harmonic analysis. But later, the same kind of hidden connections were found in other areas. And so where my original entry point was very far away from the original Langlands, but I took it, sort of made it my life's project to kind of understand every facet of, or as many as I could of the whole thing. And kind of that's what ended up doing. And so I didn't really work in number theories per se, but I worked in what's called a function field analog of that, and I worked in geometric constructions, and then physics also. So my most recent work is on exploring the links between these ideas and quantum physics. So I go back to my childhood dream. Now I want to add something which is kind of interesting, because Langlands he's 81 years old now, is a professor emeritus at the Institute for Advanced Studies, still very active mathematician, so on. I have collaborated with him, spent a lot of time talking to him, really inspiring mathematician and human being on many levels. He's just been honored with the Abel Prize, one of the major awards in mathematics. And so I had the privilege and honor to be present for the festivities in Oslo just 2 weeks ago, and I gave one of the Abel lectures, one of the public lectures, following the prize ceremony. So it was kind of an interesting time for reflecting. Of course, in my book, Langlands Program was a central point of my book, and I guess it was the first time that there was an attempt to, my book was sort of an attempt to convey the major ideas of the Langlands Program to general audience. So I put a lot of effort in terms of trying to popularize, I don't know, try to explain it in a sort of elementary way. And I've done a lot of other things around of that nature, lectures, videos, etc. But this was interesting because it was also kind of thinking about the mathematical legacy of Langlands and what does it mean and what is it that we're doing in mathematics. So it was a very kind of a joyful moment in some sense. So that somebody, also seeing him because he's such he set such a great example of someone who really, in my view, truly cares, is passionate about mathematics. He doesn't care about prizes so much. I think he did come. He would have, if he had a choice, he wouldn't have come to Oslo. But I think he didn't want to deprive us, the family of mathematicians who work in the Langlands, in the subject of Langlands Program. He wanted to give us a chance to rejoice and to have a reunion and have fun, So while he was there, he was just purely focused on his latest project, and he didn't care so much about anything else. It was kind of beautiful to observe, and that's the thing which I love about my community in general, and being part of it. Also being here at Luminy, because it's such a storied place too. I've been coming here. My God, I tried to count yesterday how many times. I think 8 maybe, but maybe more. It's a very important, and it's been, there's been some very interesting conversations and meetings and lectures, etc. over the years. It's each time, maybe I'm becoming more so sentimental now, but I feel it is such an interesting thing to be, my community, you see this passion, and I'm not saying that in other fields, other areas, there is no passion, I'm not saying that. Of course, there's passion everywhere. In fact, that's the only true things can come out of passion, in my opinion. They cannot do it, but if you do it like, it's not really going to resonate with anybody. But here, you just look at the face, at the eyes of these young people who come, there is this passion. And it reminds me also of my own, of how I did, how I wanted to become a mathematician or to prove important theorems, etc. It's really hard to put in words, but it's a kind of I appreciate it more now when I see that, and I kind of understand better why I chose. There is something that it's love. So in that, people ask me why, the book is called Love and Math, So, and the point is that I didn't quite understand when I was writing it, perhaps, but now I understand better that. That which has lasting impact or influence or any meaning is that which is driven by love and passion. Love, passion is kind of synonymous. And where it comes from, we don't know. It comes from the heart, or you could say, but it's okay. So it comes from somewhere, and wherever, it doesn't matter whether we know where it comes from. We know what matters is that we know it when we have it, when it's here. And I feel that we don't talk enough about it because we pretend, it's very formal. People go and they give a talk, a lecture, and so on. And of course, that passion is between the words or not, and you can always tell when there is and when there isn't. But I think for young people, it would be very useful to see that it's not about achievements and who did something first and whatever, like credits and so on. That's what it looks like sometimes when you grow up and when you're a young mathematician. That's why I want to speak about it, use this opportunity. So hopefully somebody will see it, maybe, and maybe it will resonate with someone. That it is really follow your heart. It's really, people ask me, what should I do? Should I study this? I say, just follow your heart. And what does it mean? We don't know, but at least we know what it's not. It's not about trying to get a better job or trying to get recognition or award or a prize. It's not. That comes maybe separately, but you don't. It has to be unconditional love, unconditional passion, and that's when magic will happen. That's when you can have things like, wow, my God. Anyway, I keep blabbering, so maybe you should move on to the next question. I had a very strange math education upbringing. So one of the reasons was that I was not accepted to university because of anti-Semitism. In the Soviet Union, I was failed at the exam at Moscow University. Perhaps, since it is by now very widely discussed, and particularly in my book, I should probably not get into details, so whoever is interested in that can just read it in the book. But the fact of the matter is that I was 16 years old, I applied to Moscow University, I was failed ruthlessly along with hundreds and thousands of other kids, innocent kids who were singled out unfairly. Okay, and so I ended up in this strange place called Oil and Gas University, and it looked like there was no way for me to continue and to do mathematics, even though they had good classes in applied math, but it was not the same. And even to enter Moscow University, you had to have an ID. And so with my friends, we actually scaled the fence on the side of the building. But still, there was this sense of not belonging, the sense that they don't want me in there. And it was weighing on me. So I think it was kind of going down. I think I was on the verge of quitting. But I was lucky because one of my professors at this school was Varchenko, who is a prominent mathematician. And he somehow he introduced me to another prominent mathematician. His name is Dmitry Borisovich Fuchs. Here is another Russian name for you. And Fuchs gave me my first problem. And Fuchs, so this was an absolutely incredible, also in retrospect, incredible act of generosity and love on his part, because he was not affiliated with my school in any way. So why would he waste his time on this kid? It was, how old was I? I was 18 years old. I just turned 18, 2 years after I was failed at the university. And yet, he was inviting me to his home. Every Friday I was on my way to my hometown on a train, and his apartment was on the way to the train station, and I would go at 5 p.m. I would go to his place on Friday, and he would talk to me for 3 hours, and his wife would prepare dinner for us, and then I would be on my way, so get home around midnight. It's incredible what people do. And so adversity, of course. If there was no problem of discrimination, maybe Fuchs wouldn't be doing that, because the system would sort of take care of students in a proper way. But because he knew that many students like me were wronged and treated unfairly, so he wanted to contribute and help. Maybe he could not help everybody, but you could help one or two. And he did, and it's so beautiful. So I'm very grateful. So I like to speak about this more, because I think we all have the opportunity to help others like this. And sometimes we do, sometimes we don't. But it's important to acknowledge those who do, and to be grateful. So I am very grateful. And so he gave me my first problem. And it was not exactly what I ended up doing. So this was kind of separate. It was about cohomology of braid groups. And I didn't know at the beginning. So see, I'm 18 years old, so on the one hand, I'm denied of doing like a regular study. On the other hand, I am now doing cutting-edge research. But that experience of being denied, being rejected, gave me such a supercharge of energy that I have to prove to those guys that I'm really good. That I solved this problem within 2 months, even though it was not good for me because I lost sleep over it. So then for several months I couldn't sleep well. But I was able to do it. And it was a very interesting thing, because suddenly it was really this moment where a eureka moment, like you said, when suddenly you look at this pattern, because you have to calculate some numbers for the so-called Betty numbers. You have to calculate not just for one braid group, but for many. In the braid group, there is one braid group for every positive whole number. So there's braid group for 1, for 2, for 3, for 4. Again, I'm not going to explain the details, because I'm actually explaining it in my book. So, and I saw how you could solve, if you already know for 1 to 3 up to n minus 1, then you can see for n, they kind of all, suddenly they all conspire together to give the answer. And it became a very nice pattern. And I was just so shocked by it. I was like, wow, my God, this is amazing. So this was this moment, electrifying. And then, of course, you can say it is like the first kiss, you can say all kinds of things. None of this is actually, so the best analogy is, we all have experienced this joy with something. It doesn't have to be mathematician, everybody. When you do something and it works, and it goes effortlessly, smoothly, like you're just gliding, you're just like flying, and that's that moment. And that's when, yes, and then when you do that, and it's like, okay, I got it. So now I want another. I want to do it again. I want to do it again. Yeah. So I mentioned some of it. So I have been here many times, and I love the place, and I'm very grateful also for the staff. Who kind of staff is mostly invisible, but is very caring and loving, and that's very, very. It's felt. It is felt. Even if sometimes we don't talk about it. Maybe we should be more, acknowledge it more. But I do feel it, and that's why the place is so special. It's all because of the care of the love of the people involved. So I'm grateful to all of you. And this is a very special conference for me, because it is in honor of my very dear friend, Nikolai Rishtikhin, who is not only a great mathematician, who has, to his credit, some of the greatest achievements in representation theory, and such as quantum groups, Rishtikhin, first example of quantum group, Rishtikhin, Kulish, Tlanin, but also Rishtikhin to Rife and variance, and many, it's a very long list. He's one of the really top people, but also a really wonderful human being, and really, really great human being. So it is nice to see his friends, colleagues, and students. Especially, it was organizers. Amongst the organizers, the ones who did most of the work were his former students, and that's how you can always tell, because that's also love. It's also that they want to honor and recognize and do something nice for their teacher. If he wasn't a good teacher, even if he had many students, they would not want to. And they do, and he has a number of students, former students, who are themselves now great, young mathematicians. But also they put their heart in this, in the organization. I was part of the organizing committee as sort of one of the senior people, so I was participating in the decisions, but I wasn't really doing much by way of organization. But I was very heartened by the involvement of some of my younger colleagues. So it's kind of like a family gathering in a sense, and because everybody likes him. He's one of the most likable people you will ever meet amongst mathematicians. He's always smiling and always positive. So it's really nice to have this gathering, and we have, in addition to lectures, also a lot of conversations and laughter, and sharing meals and wine, etc. So today we're going to have our bouillabaisse. It's going to be fun. So it's an important subject, So behind me there's a blackboard which is describing some of the fascinating stuff that has been happening in this area of representation theory of quantum groups, and the way they are now connected to geometry, algebraic geometry, and quantum physics. And so my work was on, even though it was on Langlands, but it was sort of, in part, was kind of uncovering some of the Langlands patterns in this area. So it's very close to my research as well. And so many of the themes which are being discussed, the themes which kind of been recurring for many years. And it's very nice to see some of the people whom I saw perhaps, 10 years ago, 20 years ago, working on these problems now to report on their progress and their results. It's very interesting, never-ending. It's beautiful to see this never-ending quest for truth. How is it like? What is exactly? I want to understand. And then, at first, looks impossible. It's like, oh, it's going to take forever. We don't know how to do it. And then, boom! A few years later, yes, here's the explanation. Mathematics gives you this illusion that things can be resolved. In life, most of the things are never resolved. You just learn to live with them and kind of accept them how they are. But in mathematics, actually, there is this additional element where things actually are resolved. So boom, and you have a solution. It's very hard to get to this point. But if you do it, it's really, really nice. So this is another aspect of it, that I think the area has been very successful in the last few years. So that we have, every talk presents something new and exciting. First motivation was to share with non-mathematicians what mathematics is about, and to kind of say, look, there's all these paintings of Van Gogh and Picasso, to speak. That's not just painting fences and walls, but there is also this beautiful art. It requires a little bit of preparation. You cannot just look at it. You have to have a little knowledge. So I try to. I think that most people have been so traumatized in their math classes because of how they are so focused on solving problems. So this is where this beauty of solving is turned against us, because its beautiful thing is I can solve it, and let's look for the solution as a kind of a game, as a kind of a project together. It's a share. That's a great way of using it. Now, a terrible way of using it is to say, you have to solve it now, or within 15 minutes, or within 1 hour in the exam. And if you don't, you're stupid, This is how we kill the interest in mathematics in most people these days, most kids. And they become terrified. And when people terrified, they think that they can never understand what mathematicians really do. Nor do they have any interest, frankly. But even if they do, they probably think, in my experience, in my conversations with others, they just think it's so much harder. But it's not more harder than things we know. Things like DNA or Heisenberg uncertainty principle. So people don't know the details, but they know that it exists. And in principle, there are many physicists who have done a much better job of explaining what it's about. And I felt that we were lacking that in mathematics. In part because we are kind of not very social creatures in some sense, relatively speaking. So it's a very lonely profession in some ways, because you often work alone, or maybe you work with one person and so on. It has its own charm and its own beauty, but it kind of does not encourage us to go out and share with others. And so we kind of stay quiet about it. So that was I was like, no, it's my duty to share. That was my main motivation. But of course, I also realized that at the time when I was writing it, I wasn't quite sure that that there was a second motivation, important personal for me, to also talk about some of the episodes of my personal life. For instance, that experience at the exam when I was failed, etc. So that was one of the things I was being pushed sort of by that. To express that, to share that as well. So it started out in my conscious mind was under the impression that I'm trying to teach others something, but actually in many ways I was teaching myself too. I was learning myself as well. And so anyway, the point is, it's not important. I now realize that in some sense, it's not important that I did not understand what I was doing, but I was doing it sincerely. I was writing, I was not trying to do it just to, to get to as bestseller and so on. I wasn't, okay, maybe I thought about it. It was in the back of my mind. Yes, maybe. But it was not the main. The reason, I spent I made a big effort. Why? There was something, it was no choice. I had to do it. And so, and that's why perhaps it resonated with people, because it was sincere. And I was sincerely trying. Some people who read this, sometimes from readers, they misunderstand that. They think that it's important to understand all the details. It's not important to understand. We don't understand. Mathematicians, we don't understand. I write it in the beginning. I don't understand 90% of the time. It's normal. So people get frustrated, and I understand why, because that's so deeply instilled, this idea that you have to understand. They have to be explained so that I understand. Okay, but the best response is from people who I find, and the most heartening for me is from people who tell me that they thought they never know anything about mathematics, that they are so bad in math, they never understand anything. So they come without expectations to the book, and suddenly they were caught up in this vortex of passion and energy. And even if they didn't, they tell me, I felt your passion. It's like almost I looked at it through your eyes. And that's the best, that's what I think was the best compliment. Well, so that was before the book, right? So the book was published in 2013, and the film I made a film with a French director, Frenkel, and a wonderful crew, a wonderful group of dedicated people in Paris, actually, in 2009. So that was some years before, and it was premiered in Paris in 2010. And then played in a couple of film festivals and got some good reviews from some serious people. So it was my first attempt to break through what I felt was a wall of misunderstanding. So where, for instance, I felt that people were willing to listen. For instance, I say, "Oh, you're a mathematician. So what do you do? What do mathematicians do?" And I think they sincerely ask. But the problem is that if we transpose it to my analogy with art, then it would play like this. Imagine that in art class you only teach you how to paint fences and walls. Okay? So then later on you meet in a party or in a dinner a guy who says, "I'm an artist." And you in your mind think, he's a guy who paints fences and walls. And you say, okay, well, I don't understand why it's interesting, but perhaps he needs to find something in it. So I'm curious, what do you find? So I ask, what do you find in art? What I'm actually thinking, what do you find interesting in painting fences and walls? But he thinks, he's being asked, what is interesting about art? And he says, art, it's beautiful, you can paint these paintings. But the other person, they've never seen it. They only saw paintings and fences and walls. So it's complete miscommunication. And the guy starts explaining, and they go like, oh, and you can see, after 30 seconds, it's completely, boom. So I thought, how can you possibly knock on that door, how to break that door, that wall? They have to do something totally radically different. And so what we did is a completely crazy thing, actually, in retrospect. I cannot believe that I went for this, I guess, well, my co-author was is in part also responsible, because she is very radical as an artist. And we were kind of encouraging each other, I think. And so the key idea was, what if you show a formula, not written on a blackboard like normal people do it, but make a tattoo of it on the body? And I was just fascinated, because to me, it represented something. It's like part of the body, so you embody that. It becomes visceral. It's not anymore cerebral, just on the level of the left brain, which was closed to us, to me. I felt like we are closed. The left brain of most people are closed to mathematics because they don't want to hear about explanation. Or they will want if you catch them somehow in other ways. But once it becomes part of the body, so it's something else. Suddenly it's part of the body, so wow. First of all, it looks different, right? So also, it's like it gets under your skin. So anyway, I was fascinated with this. And then, so then of course there was also another influence was, another very inspiration was from unlikely source, was a Japanese author, Yukio Mishima. So Mishima is famous for his writings. He's really one of the most amazing authors of the second half of the 20th century. But he also made a short film, which was called Rights of Love and Death. And somehow we came across that film when we were thinking about how to, because we had the idea, the tattoo formula, but how, you know, so, and boom, then I see the film by Mishima. In the Mishima's film, actually, there is no tattoo, so interesting. But somehow I was completely possessed by Mishima's film, and I wanted to do the film just like that. So we kind of follow his structure. It's set on the stage of Japanese North Theater. So it's completely, so everything is completely, I don't know how to even, it's mad. The whole thing is complete madness. But it's interesting, it does have effect. So it did excite people who watched it. Some people really got it. Because it's really unusual. It's like, wow, suddenly you are on in a totally different plane, in a totally different framework. This mathematics comes, and the passion of it. So what I see now is that what I really wanted to convey is the passion of doing mathematics. How to do it? I mean, you cannot explain in words. So art gives another medium. Cinema gives another medium. And that was the point. That was the idea. So that was an attempt. I was not satisfied with it, I have to say. I was not satisfied. I mean, I am proud of it. I'm proud of it, and I'm proud of the effort of those who worked with us. But I was not satisfied because I felt that it had many shortcomings at the technical level, etc. So that's why then I said, you know what, I have to do it as a book. This is not going to work. It's not enough. So that it pushed me also to write the book, and gave me the title of the book. Because since Mishima's film was called Rights of Love and Death, we call our film Rights of Love and Math. And then Love and Math became the title. So in some ways, Mishima also influenced the title of this book. So that's more or less the story. Yeah. By the way, it is now, interestingly, there is now a website called labocine.com. Labocine is a kind of a depository of short films. They call it New Wave of Science. So there is this guy who, I forgot his name, but Alexis, I forgot his last name. He has a festival which is called Imagine Science Festival, a film festival, and he and his colleagues have started this thing a couple of years ago. And they asked me if they could place the film on their platform. And it's a very nice platform, very well done technically, in my opinion. And so it has been, so one can stream it actually on that platform. So now it's actually available online.